Hello and welcome to another presentation in the LADAL Opening Webinar Series 2021. My name is Martin Schweinberger, and together with Michael Hoare, I'm co-directing LADAL, the Language Technology and Data Analysis Laboratory in the School of Languages and Cultures at the University of Queensland, Australia. Before we start, I'd like to read out an Acknowledgement of Country, which we do here in Australia to express respect and gratitude towards the Indigenous people of Australia. So I'd like to say that we, as members of the University of Queensland, acknowledge the traditional owners and their custodianship of the lands from which we're broadcasting this webinar. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. I would also like to say that we recognise their valuable contributions to Australian and global society. If you want to know more about LADAL and the resources we provide, please feel free to explore the LADAL website. The URL of the LADAL website is shown on the screen. No worries if you've missed any of our talks. Most of them are freely available on our LADAL YouTube channel. You can also find information about past and upcoming presentations in the LADAL Opening Webinar Series 2021 on the events subpage of the LADAL website. If you want to keep up with what's going on at LADAL, please feel free to follow us on Twitter or on Facebook. And if you have any suggestions, feedback, or comments, please do not hesitate to reach out to us via email. So without further ado, it's my pleasure to introduce today's speaker, Stefan Guillou, who is a great colleague of mine here at UQ. Stefan has worked for the last 10 years at the University of Queensland. After completing a master's degree in plant science and ecology in France, he worked in research around the topic of sustainable agriculture. In 2018, a drastic move to a technology trainer position at the UQ Library allowed him to share data analysis best practice skills and promote open source tools for research. He's motivated by the principle of open science and the opportunities an increasingly collaborative research ecosystem offers. So I'm very happy to hand over to Stefan. And there you go.
Thank you very much, Martin. Always a pleasure to try and help out and be a part of this. I can see my background doing funny things to my face. I will share my screen now with my presentation. Okay, so today what I want to talk about is this system called Git, this software called Git, and some platforms related to that version control system called GitHub or GitLab, or there's a lot more that we can talk about, but there's pretty big players that we probably have to focus on for obvious reasons. But yeah, hopefully today I can give you some idea of how this might be useful, how to get started with it. It's a bit of a beast of a piece of software, but you can get started with just the few essential actions you need to understand to use that system, and hopefully it becomes a tool of your toolbox to keep track of versions of your project and more easily find issues in your history or roll back to a previous version. So I've got this little slideshow to share a few of the most important talk points, and most of the session is really a hands-on session, so it might be different to the other webinars that you've seen in the LADAL webinar series. But hopefully that's a good way to maybe remember a bit more how to use the tool and put it in practice really soon after. If you are interested in using these slides or using the links that are in the slides, there is a short link here that Martin has shared in the chat as well, or you can also use that QR code to get to the same spot. Now, if you follow that link, you'll get to a Git repository, which is what we're going to talk about today. On GitHub, this one, and to download the files, you can go to the big green code button and download a zip file where you will find this HTML slide deck. So you can browse it on your own computer and keep the files with you. So, well, one big question would be, first of all, why would one want to use Git? Also because it can get quite hairy, quite tricky to use that system. As I said, it can be a very complex tool if you're aiming at using a lot of the functionalities, but you can also focus on some of the most essential ones. And in that case, just the things that really matter to you. And in that case, it's not necessarily the most overwhelming thing. But it was designed originally for working with other people on a big code base. It was very much directed at working on software, collaborating with others on the same code. And it allows developers and researchers as well to build a very precise history of a project. Now, with Git, you will store versions of text files, and that's really an important aspect of it, is that it is designed to show changes in text files. So it's not necessarily a good tool to use with, for example, big binaries. Or it really is designed for versioning code. But because it is text files, you can really use it on anything that is text-based. And there's quite a few formats, quite a few standards that are text-based. And you will see people using it for writing their thesis, or you will see people using it for publishing websites. You will see people for using it for storing versions of datasets as well, as long as this is text-based. So really, this is an important aspect here. It's the precise versioning to track and potentially roll back in the history of your project. So you decide when it matters to store a version, or rather store a change in your files, and you decide what the description of that change is, as opposed to maybe a system that, well, might not even have any versioning integrated, or you might just possibly be able to undo some operations, but doesn't really integrate an obvious versioning system, or other systems that do keep versions, but do that automatically without necessarily asking you, is this a good version to store? What has changed in this one? What is the objective of the change? So you have the power to define exactly what is stored, when, how it is described. And you end up with this if you work with other people, you end up with this very, very clean history of only the versions you wanted to keep and the versions that say exactly what has changed and who has done the change. So it does bake in that idea of collaboration where you're able to work on the same project at different times, potentially on the same file, and then give you the tools as well to merge different changes. If you were working on the same part of the project, same part of the file, it still gives you the option to get in there, compare the changes, and then arrive to a consensus and then keep the version that everyone's happy with. And there's a whole ecosystem around Git. We've already mentioned GitHub and GitLab. They're Git repository hosting platforms, where instead of just working on your computer with your own personal Git repository, working just on your copies of your files locally, you can link that to an online platform that gives you not only a spot to host that repository and then collaborate on that same reference with other people, but also gives you the option to add extra features around it. For example, reporting issues or getting contributions from people who are external to the project, dealing with who has access or not, etc. And we might see some of those features later on. And finally, it is an open source tool. It is a bit the reference versioning tool. At the moment, it's used extremely widely. And just as an example, to illustrate what I just said, I just want to go to the repository that hosts, or at least has a copy of the code for the Linux kernel, which is hosted on, well, this one particularly is hosted on GitHub. And for this particular project, you'll see that there's more than 5,000 contributors to just this one project. And there's more than 1 million changes that have been made to the same project. And it's really because of that tool, Git, that this kind of collaboration is possible. The development of Git is actually very much linked to the development of the Linux kernel. So you might want to use it on your own. You might want to use it with other people. It really doesn't matter. It's about finding the bit of it that is useful to you. If you have questions during the presentation, feel free to ask them in the chat, and Martin will moderate those ones. So to install this tool, again, it's open source, it's free. You can install it on the major operating systems. On Linux, you should have that already available out of the box. For any Linux distribution, you should have already Git installed. Now on Windows and Mac, you might have to install that yourself, and we've got a couple of links here if you need them. Git for Windows is probably the easiest way to get that. Put that in the chat as well. And the smaller one for macOS is possibly this Git installer. But it also comes bundled with Xcode. The alternative with Windows is to install a whole Linux system inside Windows, which is called Windows Subsystem for Linux, and that gives you a very integrated and full Linux distribution inside Windows if you want to use more tools, not just Git. But for today, if you want to follow along, Git for Windows will be enough, and the Git OS X installer as well. So now what I'll do is I'll show you how you can use Git with a command line, which might seem extremely dry to start with. But I think it's a good way to get introduced to the tool because it really focuses on the names of the actions, the precise names of those actions, of those essential functions. And then you might want to move later on to a tool that integrates Git in a graphical user interface, or you might want to use Git only on an online platform. That's also perfectly possible depending on what you do. But starting with a command line and just white text on a black background and writing those commands by hand is, I think, a good way to familiarize yourself with the process of storing versions of files or changes of files. So we'll start with some main Git actions that I'll list here. We'll start with setting up a Git repository. We have to tell Git that this is a place where we want to start tracking what changes in files. And then we will use some more commands to check the status of the repository, and then we'll start recording changes. So we'll go together through those ones. If you are on Windows and you've got Git for Windows, you should have a tool in your Windows menu called Git Bash. Git Bash, that's one way to open this kind of terminal interface. Git Bash. On macOS, you should already have a terminal. In my case, I'll open the terminal and set up a directory to start tracking files. So I'll go to my files now, and in any directory that you want on your computer, anywhere that feels like a good spot and that keeps things nice and tidy. I've just created on my desktop a directory called Git Workshop. You can name it whatever you want. You can name it maybe something a bit more descriptive. And just for today's example, we'll use the example used in the carpentries workshop about Git. We'll talk about planets where we can move if we decide to move away from the Earth because we've made such a mess. We'll start storing in a couple of text files, a bit of a debate about where we are going. So in this directory that I've just created, what I'll do is create a new text file, a new document. Let's say it's an empty text file with an extension txt. Maybe I'll give it a name that's a bit more descriptive. I'm going to call it Mars. And in this file, I'm going to start taking notes on this planet. I'm opening any text editor that you want to use. I might use this one here. Start taking notes about Mars. I'm going to say that this planet is cold and dry, but everything is my favorite color. And I'm going to save this change. So this is my first file. This is my first change. I'll see now how I can go about using Git to start recording changes to my project. I'm going to start having also other files that I want to track. What I can do is open a terminal in this directory. So on my computer, I can right click and then open this directory in a terminal. And I might zoom in so it's a bit more obvious what I'm doing here. I can see in my prompt here that I'm in the right location. I'm on my desktop in Git Workshop. And I want to start tracking what is inside this directory. To do that, I'll have to initialize a Git repository, and all actions that you do with Git will start with Git, a space, and then the verb of what you want to do or the action. So here I'm going to use the command git space init for initialize. And it tells me here there's a bit of feedback that it initialized an empty Git repository in the current directory where I'm located. So inside Git Workshop, there's this new Git repository that is actually hidden. It doesn't show here, but if you decide to show your hidden files, which I can do here, show hidden files, I'll see that there's this hidden directory where everything happens in the background. When you've got a Git repository, it will save all this history of changes and it will be stored in there. So this one, we really need to just leave it alone. We can forget about it. That's why it is hidden by default. So I can hide that again. Now to make sure that I'm recording my history as I should and identified properly in my history, I should also do a little bit of configuring my installation of Git. So what you can do is use the config verb with git config and set up some global options using this global flag or this global option. So using 2 dashes and saying global, you're saying that you want to set that option for the whole computer for any Git repository that you're going to create. And in here, you can specify which username you want to use. So user.name, and in between quotes, you'll say that your name is your name. And after you've executed that, you can also make sure that it's using the right email as well. And these are really the 2 most important bits of information you'll want to have identifying your changes. So again, I'm going to use a very similar command here, git config. It's a global change. And this time it's a user email that I'm going to change. The one that I want to use here is this one. Now, if you are using GitHub or another platform like GitHub, you'll have to make sure that you're using also the same identifiers. So these two, Git config global username and Git config global user email. Now this should really only be done once. Now, anytime you initialize a new Git repository, you shouldn't have to do that again. It's done unless you want to change it. So now that we've initialized our Git repository.
Stefan.
Yep.
I'm sorry to interrupt, but I have a comment about this.
Sure.
Because I tried that the other day and it didn't work. I think at least the Git version I had required that you actually have to set a PAT, a personalized access token.
Okay.
Just to let you know. So this might work for most versions. For some versions, you might have to create a PAT.
Okay, so I assume that is if you link it to Git when you do link it to GitHub. So
Yes,
eventually,
yes, that's true.
once you link to GitHub, it's true that GitHub recently have kind of tightened their security around accessing the API, accessing your account, and therefore accessing your repositories that you're hosting on GitHub. So there's a few ways to do that. They have a command line tool, the GitHub CLI or CLI, so command line interface that you can use to authenticate yourself, or alternatively, you can use a personal access token, as you said. So there's the two options. Today, what I'll do when we start actually linking to GitHub, which we're not doing currently, we're really working only locally here. You might have to deal with that.
That's right. Yeah, sorry about that. You're right.
Oh, no, that's all good. It might be, I'm not sure how it would go, but I've never really done that with the GitHub command line interface. It might be that as soon as you use that tool to do your Git work, you have to authenticate yourself. I'm not sure about that. It is definitely possible. But if you use the command line interface provided by GitHub, it also means that you're kind of tied to GitHub, as in it's integrated with GitHub. It might not, I'm not sure, but it might not allow you to use it with other systems as well. But yeah, that's definitely something I should explore, because it's definitely a tool that's becoming more popular. But yeah, thanks, Martin. So if you see a mention of that, of a personal access token, you can look up GitHub personal access token or PAT, and you'll find all the documentation on how to create one. So we've got our system configured, so it knows who we are. We've initialized the Git repository in the current directory. Now I can use that Git status verb or action to, at any stage, at any time, see where we are at. What's the situation with this Git repository? Currently, it says that we are on branch master. So this is talking about branches, as in you can really picture it as a tree. Imagine you've got a project with different branches where different changes happen. It's possible that if you've got a very complex project, you've got several branches where you might have a more stable branch that people use on their computer, install and use every day, whereas you might have an experimental branch where you have more dangerous changes in the code base. So eventually you might even have branches that merge again once maybe that branch has matured a bit more, then it becomes the main one again. So there's all sorts of things that can happen with branches, but for a lot of people, you don't have to deal with those ones because you've got just one single trunk, let's call it. It says that there's no commits, which means there's no recorded changes in your project so far. We haven't really recorded any change that's expected. And that's really a term that's going to come up a lot, commits, which is when you commit changes to the history. So you record changes. It also mentions that there's, in red here, a file that is not currently tracked, an untracked file. And that's our only file in the directory, as you can see here, that we just created, mouse.txt. It doesn't know yet, Git doesn't know yet what to do with that file. So the first thing we have to do is tell Git, well, this file, mouse.txt, I want to start keeping track of what changes in there. So when you want to start recording changes, there's a two-step process where you first add a file to what we call the staging area with the add command, git add, and then the name of the file, mouse.txt. Press enter. Now if I do git status, which I don't have to, but I just want to see what changes, git status, it looks different. It tells me that we've got a new file called mouse.txt. Now it's in green, and it knows that this is something that will be committed as a new version. The change will be committed to the history. And the second step in the process would be to commit. But every time you commit a new version, you absolutely have to describe what has changed. So in this case, a lot of people just describe the first change as first commit or initial commit, because you start tracking files. There's really not a change per se, but here we can say that we start talking about Mars as a new place to live. So we can say, consider Mars as new base. So see the structure of this command. This is something that if you use Git, you will be familiar with fairly quickly. Git commit, we want to commit changes to the history. The M flag with -m, oops, sorry, -m to say message. We are attaching a message to this change. And in between double quotes, you have to open and close those double quotes. Any bit of text, concise but descriptive enough to describe what has changed in the project, what the change is related to. And when you press enter, you get a bit of feedback here. It tells you that one file has changed, how much has changed in the file, and it gives you an identifier for the commit. It gives you the text that describes the change as well. So we've been through adding a file and then committing the change, which sounds a little bit redundant to have two steps there, but you might make it more obvious later on why we have those two separate stages. Now I want to go back to my slides, go through those actions again. So initialize, this one, you don't really use it that often. You initialize the repository when you want to start tracking it. So that happens once at the beginning of a project, and then you don't really need to use that again until you have a new project, new separate project. Git status is really one that you use as often as you want, as little or as much as you want, to check what's going on, what's the status. Is there files that Git doesn't know what to do with yet? And then we've got the recording of changes that we'll go through over and over again, which is the two-step process of adding a file to the staging area and then committing the change with, very important, a description with the M flag, a message. So we'll see this process a few times today. I might want to go back to my file and add a little bit of extra information. I'm going to say I might push this to the side and open my text file once more. Just a simpler text editor. And here I'm going to add an extra line. I'm going to say, apparently you can grow potatoes and save that. So remember, this change has been saved in my file, but it hasn't been saved as a change in my repository. I can save this file as many times as I want, do lots of changes. I decide when I store a change in my history, in my Git history. So going back to my command line, I can now maybe try again a Git status. So I'm here at the bottom right, Git status. What's the situation is. Now it's slightly different to before. It's not a new file, but it's a modified file. Mouse.txt has been changed, but the change hasn't been recorded. So if I want to store that change again in my commit history, I'm going to go the two-step process, git add mouse.txt, and finally git commit with a message. I'm going to say mention agriculture in between the double quotes. And again, that change has been saved. I've got one file changed. I've got two insertions because I've got an extra line here, an empty line. And that's now in my history. So this process can be visualized with this following picture. You've got your Git repository in gray shaded area here. That's your .git directory where everything is saved in the background. You've got your file on your computer with a change. That's the addition, the line that was added in green here. And using git add, we're putting that change in on the staging area. And then with git commit, we are committing that change as a version in the repository, in the history. And you can really picture that history as a stack of changes with the most recent one at the top. So what if I want to see what has happened in the history of a project? Back in my command line, I might make this bigger. I can go git log to see the history. So it's a log of changes. Git log, press enter. And there's only two changes here. Now you can see the precise description of what has changed and when it was changed in the Git repository. There's a description. This is the oldest one. Consider mouse as a new base. Who edited it, who did the change, and precisely when it happened, or when at least it was recorded. And you've got a unique identifier of the commit. And at the top, you've got the most recent one, this one here, mention agriculture. This is also called the head. So it's the top of your pile of changes, like we've seen on the picture. And so it's the head of that stack. And as you commit versions, you'll have this stack growing and growing and growing. Right. So about this two-step process that might seem a bit redundant, let's imagine that you're considering Venus as a base now. You might want to start a new file. You don't want to put everything together in the same file. So let's create a new document, a new text file. I'm going to rename this one and call it Venus. In mars.txt, I still have it open from before. In mars.txt, I'm going to say, maybe Venus is better. I'm going to mention that I'm considering that in the mars.txt file. And then I'm going to start documenting in venus.txt why I might want to consider this one. So I secretly have to look up information about Venus to actually put something in there because I know nothing about our solar system. And I'm going to say second planet from the sun. I'm going to say maybe a bit too hot. And save that new file. So now when you think about it, we've got two changes in our project that are related, that are about the same issue. So when I go back to my Git commands, I'm going to say that I want to add two files now. I'm going to git add mouse.txt. And if I want to, I can keep going and putting other names here. And git add venus.txt. I could have done that in 2 steps, but I can also go one single command, git add mouse.txt, venus.txt. And then save both those changes as one single commit. So git commit m, and the message is, you can see that Venus is a better option. So I've saved that new change, or those changes together as one single version. And it tells me that 2 files have changed this time. If I look at the log, git log, there's now 3 commits. This is the most recent one. And you can visualize that as a slightly different picture, which would be this one. So multiple related changes. You can imagine a big piece of software where you've got a new feature that requires you changing bits of code in several files. It might be a file about the front end, what people interact with. It might be a file and another file that deals with the data, and another file that deals with the back end, what happens in the background. So several files changing for one single reason. And that's exactly what we had here. File 1 would be master.txt, file 2 would be venus.txt, for example. Both are added to the same staging area and then committed together. The changes are committed together. Similarly, you could have a project, a data science project, where you do a change in your analysis, but you might have to do changes for that to happen in the data cleaning script and the data visualization script. Right. So we've seen how to initialize, check the status of the repository, add changes to files on the staging area committed to a new version. And we've seen also the history, how to see the history with git log. But now let's talk about how you can link your local repository, and instead of just working on your computer on your own, you can link that to something online. And this is what we call remotes or remote repositories. So it allows you to sync a local project with an online copy. There's a lot of reasons why you would do that. You can consider it as, for example, your backup. So if something happens to your computer, you still have that remote, that online repository. Also using one of those platforms like GitHub, GitLab, Bitbucket, Gitee, Cogs, Gitbucket, etc. There's other alternatives. There's a link here if you're interested. You can use those extra features. So I've got a link to alternative 2 to find the one that suits you if you want to filter, for example, for self-hosted options, if you want to host your own or only open source ones. And you can see the popularity of some different ones as well. So those are alternatives to GitHub. You can use those features to interact with other people, to attract contributions to your project. And potentially also be the reference point between several computers that you have. You might have a personal computer and a home and a work computer that are linked to the same remote repository. So how do we deal with remotes? There's again our main Git options. And here we're going to add 3 words that might be useful here. Git clone, Git pull, and Git push. First of all, we have to make some space somewhere to host that remote repository. So today we're using as an example GitHub. That you've already seen that GitHub page where I've got my slides stored. This is a dedicated repository just for this deck of slides. If you're logged into GitHub, if you've created an account, but it will be very similar for other ones. For example, GitLab. If I went to GitLab, I'll go here, gitlab.com, it will be extremely similar. I'm also logged in and I can create something new by clicking that plus button at the top and picking a new project or repository. On GitHub, you would go to the plus button and say new repository. So I decided I also want to put my planets or my example project that we're doing today online. I want everyone to see our thoughts about moving to a new planet. When you create a new repository, you'll have to decide on a name, and that's going to be in your URL also. So keeping it short is also a good idea. The owner is by default you, and here I'm going to call it planets. And you can give it a description, thinking about moving out. You can choose if your project is going to be public or private. But if you want other people to interact and to work on it, public is a good idea. And also it's great to publicize your project and kind of use it as a server to publish something. We can also decide to add extra files. It's great to have these options, but what we're doing now is only creating the space, the blank space, to then have that copy of our existing repository on our computer. So we don't really want to add extra files here. But if you were starting from scratch, if you were just starting on GitHub with something brand new, it might be interesting to add a Readme file to give easy, quick information to people as soon as they get to the repository to explain what this is, what is it for, and how you can contribute, for example. There's also a file here called Git Ignore, which is an interesting one. We're not creating one today, but if you needed to Git to automatically ignore some kinds of files, imagine data files, for example, maybe they're sensitive, you don't want it to track those ones, you can add those to a Git Ignore file, so it automatically just leaves that to the side. And also, especially if you make it public, you might as well choose a license to tell people, well, those are the conditions for reuse or redistribution, or this is what you commit to when you contribute to it. But today, because we already have existing files, we're not going to add any, so we don't have to solve a conflict between the two repositories. So I'm going to go straight to create repository at the bottom. And now we've got our empty repository. You can see the name here. That's my username here. That's the name of the repository, planets. It is public. And now I can see the instructions. I need to do different things. So depending on your situation, there's a few suggestions. The one that we're interested in is this one. We want to push an existing repository from our local computer, from our personal computer. We already have some files that we're already tracking with Git. We want to now push that to GitHub as well. And it's great that GitHub gives you that. Other websites will also give you similar instructions. It gives you 3 commands that you can copy and paste into your command line to get set up. So I can go back to my command line here. I'm going to do what it tells me to do. And in a nutshell, you don't necessarily need to understand the whole thing here, but the first one will be git remote to add that remote repository, to create that link between your local one and your remote one. You need to add that link. That's what we're doing here. That's the first one. The second one is a quick renaming of the main branch, because you might have noticed before when we did Git Status, and I can do that again actually, Git Status. It says here on branch master. So depending on your version of Git, you might have as a default branch master or main, but there's like the culture around this is changing a bit, and now it's more and more common for people to call the main branch main rather than master. So that's what it's doing here. So it's sure that it matches between GitHub and your local repository. So if I do that, git branch m main, as you can see here, git branch main m, git branch m main. If I do another git status, I'll see the new name of the branch on branch main. It's just doing a little bit of making sure it matches. And finally, the last one here is the action of pushing our changes to the remote repository. So the structure of it here is git push, that's our action. We're pushing changes or whatever we've got on our computer to the remote online. And the destination here is origin main. This is the nickname of the remote. This is the branch on the remote. Now this section here, the U origin main, we don't really have to do that again because it will be by default that with all the following pushes. So I can do that, but now, of course, it's asking me, well, are you actually the person who has access to that repository? It's a public repository, but people who can make a change to it currently are only the person who created the repository. So it is me, but I have to prove it. So I'm going to use my username for GitHub. And this is where I have to use that personal access token that Martin was talking about, or any of the authentication options available. So now that I'm identified, I've used the username, I've used the password. It will give me a little bit of feedback. So there's a lot of information in there, but basically it tells us that it has worked. It has sent all those changes to GitHub. It also tells me that the main branch is now the default one. If I go back to GitHub, I'll have to reload the page to see those changes. So there's our repository, there's our copy, online copy of what we've got locally. Now I can see some files. I can see mars.txt, venus.txt. I can see that there were 3 changes. See this here? This is your history. It says 3 commits. If you click on that, it will show me the whole history of what has changed. Consider Mars as a new base, mention agriculture, consider Venus as a better option. And I can use those tools on the side to see the differences between versions, for example. So back in the main page, code, I can also see what is the latest or the commit that has affected that file most recently. You can see the comment on the side. You can see how long ago the change was. You can see for the whole repository when was the last change. So you can see that all this information is presented in a different way. It's the same things that we've seen in the command line, but probably in a more user-friendly way presented here. And on top of that, on top of those common Git tools, then you've got extra things around it. For example, if someone thinks that there's a problem with your thinking around which planet you should go to, and I'll share the link to the repository. It is a public one, so you can go to this issues page and create a new issue. If you're on GitHub, if you've got an account, you'll be able to click on new issue and say, well, actually, maybe Jupiter. I'm going to say something to think about. So obviously this is a pretty bad issue, probably should give a bit more information. You can submit the new issue and then people can have a conversation around that. And eventually mark it as fixed or close the issue for whatever reason. And in the settings on the right-hand side here, you'll be able to do a lot of things with your repository, including managing who has access to it. So if I want other people to collaborate on this, I'll be able to change here which collaborators can contribute. So I don't know if I'll be able to find Martin on there. Yeah, I can invite Martin. And Martin should receive an email that tells him Stefan has invited you to contribute to this repository. Do you want to accept that? And then he would have access to, well, who would be able to push changes to that repository. Now, if I do a change locally, if I decide to add a file, for example, so I'm on my computer, I've got my 2 files. I'm going to say, right, well, Jupyter, maybe that's a good idea. I'm going to create Jupyter. Now again, I need to look up quickly some information about Jupyter. Open that in my text editor. I'm going to say that it's the 5th planet. Largest one. And I'm going to say, but it's a gas giant. Oh, that doesn't sound good. Okay, saving this one. I've got that change on my computer. I don't have it in my Git history. So in this case, I'd go through my usual process. I want to git add Jupyter.txt and then git commit and say that issue number 1 said we should consider Jupyter. It's committed. It's in my log. If I do git log, I can see that change. It's at the top here. But notice something interesting here in the history. Now it's telling me, watch out, because origin main, which is your remote, is only at this stage. It's only at this version here. It doesn't have the latest one. And you can confirm that by going to GitHub. Even if I reload, we haven't sent those changes here. It's still just Mars and Venus. So when you work with remotes, you kind of have to add an extra step here. You don't have to do it every single time you commit, but maybe eventually you get to the point in the day where you think, right, I'm finished, I'm going to send my changes to the remote. Or maybe better, every so often you think, okay, probably a good time to send my changes because maybe someone will be working on it as well and needs those changes. So in this case, I would go just like we did before, git push. I want to push my changes to the online repository. That's done. And if I refresh GitHub, I now see Jupyter, Mars, and Venus.txt. Just a minute ago, there was a change saying issue 1 said we should consider Jupyter. And see another integration that makes working with GitHub a bit, oh well, working with Git on GitHub really quite enjoyable is that if I mention issue number 1, it gives me a link that goes straight to the relevant issue. Now, what if I do a change on my remote repository? Or what if someone changes something in the project and submits the change to the remote repository? I don't have it on my computer, right? So there's a bit of a recommendation at the bottom here. It says, maybe you should add a README. I think that's a good idea because when you look at this page, yes, there is a little about section. Yes, there is the name of the project, of the repository, but it doesn't really tell me much about how I can contribute, how I can use it, who's who, etc. So a README file is really a useful one. I can click on that green add a README button, and it allows me to create a new file in GitHub or on GitHub directly. It has a little text editor as well. So it gives me a title here, and it's using the syntax called Markdown. You can see in the name of the file, readme.md. MD stands for Markdown, which is a markup language, very similar to HTML, but simpler. A nice way to use very simple syntax, very simple code to format some text so it renders nicely. So here there's a heading at the top of level 1. And I'm going to say that planets is about considering our options. We're thinking about moving out. Is Venus too hot? Is Mars too war-y? And is Jupiter too gassy? Now, if I want to, I can also add, using that markdown syntax, links. I can say Jupiter is surrounded by square brackets and followed by parentheses, and between the parentheses, I can put a URL. And this constitutes a link. If I want to bold this, I'm going to put 2 stars around hot. If I want to italicize it, I'm going to put underscores around it, or single stars. And once I'm happy with this, maybe I want to say also contributing. Feel free to submit issues or pull requests. And we'll talk about what pull requests are. Okay, I'm happy with my changes here. I'm happy with my little introduction to the project. And at the bottom of the page, there's my section where I can straight away commit that change. So see, it doesn't really go through the add stage here. It goes straight to the commit. It does the add in the background. But here I'm going to say, yeah, create Readme for quick intro. And you can add an optional extended description if you want, if you really want to give more information. But I'm happy with that. Commit new file. And I get my little README file here, listed here in my files, my repository files. And underneath, it also does the lovely thing of rendering that markdown. So you can really use it just like a little website, right? You've got your heading at the top, you've got your bold, your italic, and you've got your links as well. So now that change is on GitHub. Just now we've added that file. If I look at the history, 5 commits, I can see that most recent one, 36 seconds ago, create README for quick intro. But back on my computer, again, I don't have that README file here. If I want to make sure that before I do any work, I go back to my desk, I want to work on our project. I know that others are contributing, or I know that maybe I've made a contribution just online on GitHub directly. Before I do anything, it's really good practice to straight away say, all right, do I have everything? Have I pulled all the changes from the remote? And that's done with git pull. So there's that idea of pushing changes to the remote, but also pulling changes that you don't have yet locally. Git pull. And yes, there were changes, as we know. It's telling us a lot of stuff, but most importantly, the README file has changed. There's an insertion of 11 lines, and there it is. Readme.md. If I want to now, I can open it with whatever, a text editor or even a markdown editor like this one that shows me the rendered version on the right. Right. So this is the quick intro to the process of using Git, how most people might use it, the actions that are most common. So we've seen with working with remotes, how we can pull changes, get the latest changes from the remote, push changes as well to send local changes to the remote. I haven't really talked about cloning just yet, but I'll mention that in a minute when we look at a proper example of maybe a real life example of wanting to change something on a website. So we talk about LADAL. We introduced LADAL in this webinar series, this amazing tool, this amazing website with many resources. And you might want to contribute to LADAL. You might find that there's something that I'd like to change in one of the tutorials. Maybe you want to add extra information. Maybe you want to fix a typo. So in the R basics, so some introductions to the basics of the R programming language, there's a section on handling tables in R, how to import some data. And if you want to have a look at the website, I'll put that in the chat. And I noticed that scrolling down, there's a section that talks about readXL, the function readXL, and comes from the readXL package. That's perfectly right, which is part of the tidyverse. And then it says, but does not need to be loaded separately. Now, this is, so we can make this little paragraph a bit better here, because readXL is installed when you install the tidyverse, but it is not loaded when you load the tidyverse. So that's just a very subtle distinction here that we might want to clarify in this section. So what if you want to get in there yourself and try and fix that? The files for the website, the LADAL website, happen to be hosted on GitHub, and the name of this page is the table page, as you can see in the name up there. You can also see in the URL, it is hosted on GitHub, github.io. It allows you to publish websites quite easily, GitHub as well. So I want to find that one. I'm going to go to LCLC LADAL. I'm going to go to GitHub and search for SLC LADAL. Let's have a look. SLC LADAL. Now I'm searching in this repository currently. That's why I see nothing. There's no results. It says in Stragu planets. There's no result. I have to go to all GitHub, SLC LADAL on the whole of GitHub, and there it is. There's a repository. That's exactly what we're after. And the file that we're after is the one that starts with table. So I'm going to scroll down. So there's our file table.html. Might keep that like this. Okay. So it was changed fairly recently, 19 days ago, actually. I can see what has changed also by going to page updates, seeing what has changed. So it's all in the open. You can see there's a lot of transparency there. You can see what has changed on the website since it was pretty much created, as long as the change was recorded as a single change, right? So now we're having a bit of scrutiny, Martin, on your work. So I could have a look at table.html and try and spot that issue that we've found. This is the rendered HTML page. I can definitely scroll through and do even a little search and see if I can find readXL, right? readXL, blah, blah, blah. And it says here, which is part of the tidyverse and thus does not need to be loaded separately. Now, if we fix this HTML page, yes, next time the website is published, we will have fixed that little bit of information. But the issue with that is that we're not really fixing the source. If you know a little bit about the R ecosystem, there's this file format called RMD or R Markdown. Remember, we talked about Markdown just before. This is the R flavor of Markdown, which allows you to mix code, output of code, and prose text. So it's quite a powerful format that relies on a few packages to generate reports often, or HTML pages, or all sorts of outputs that are focused, that you can update in a few seconds by just changing the underlying data file, and then all the outputs will change in the document. So if I really want to change the issue at the source, I should probably go to the RMD file and find where it is in there. again, scrolling through, I can again do a search, but it should be fairly easy to find read Excel in here. Yeah, and this is the line that I would have to fix. I could do that straight onto GitHub. I could go to this little pencil button. I know that that's the file that I want to fix. I want to click on that pencil. Let's see how it says fork this project and edit the file. So clicking on that, because I don't have the rights to edit this file, I don't have access rights, I don't have edit rights to this repository. What will happen is that GitHub will create a copy of it. It will copy that whole repository, and then you'll be able to edit it and then submit that change for review to potentially Martin. So I'll click on that. GitHub does that in the background. It makes a copy of your project. It says, we've created a fork of this project for you to commit your proposed changes to. Now I've got this little editor. I can go straight in there. I might scroll down to make a bit more space. Find the line that I want to fix. And go here. It says to load Excel data from your own computer, you can use the read Excel function from the read Excel package, which is part of the tidyverse and does not need to be installed separately. So I'm going to change that. And remove this extra bit of information that's a bit superfluous. So I'm happy with my change. I've changed the source code that generates the page. And I'm going to, just like when I commit anything, write a description of the change. And say that this is that read Excel is installed with tidyverse, but not loaded with it. Also tells you that you should probably keep it to less than 50 characters. So if I've got a bigger description, I could probably put it down there. I'm going to propose the changes. The changes have been made on my copy of the repository. You can see here, Strago sc ladal github.io. So it made a copy to it on my repository, but then it offers you straight away to create a pull request. And that's, we mentioned that word before, a term before. The pull request would be sending that change to Martin, sending that change to whoever runs the repository and say, are you interested in integrating that? So I could definitely do that. Now create a pull request. It automatically adds a title to it, and then I can give some more information. So the issue with that is that we've submitted the change to the source, but then the source needs to generate the HTML page. So then there would be extra work for them to go through, well, generating the website again. Well, it's not a huge issue, but you might also want to consider at this stage, well, do I also want to check that my changes have worked? Maybe check that I haven't broken anything in the website. Maybe I want to generate the page on my computer, see the result, and publish or send all the changes to the repository. So in that case, what you would do, it would be slightly different, maybe a bit more work, but you would go to your fork that you've just created. So I might go to my profile. Instead of just submitting that pull request, I might go to my my profile that just created. Here it is. There's the repository that was forked. You can see this term at the top here. You can see how many times a project has been copied, and it's often a good indicator of how popular something is. And I can make a copy of that to then test it locally on my computer. The code button allows you to download an archive of the code, but it also allows you to copy a link. So this Git link, you can click on that button here to copy that, and then go to my computer and say, right, I'm going to go to my desktop. I'm going to open a terminal here, and I'm going to clone that repository. I want to make a copy of the one I've got on GitHub. Oops, sorry. Oh, yeah, we're using the wrong shortcut. So I'm using another verb here that was mentioned in the slides, git clone, to clone a whole repository from GitHub. And I can tell it to use a different spot. So I could say, maybe I'm going to call it SLC LADAL. So it's going to create maybe SLC LADAL website. It's going to create a new directory and copy that repository inside it. So he's telling me cloning into SLC LADAL website. And it will take a bit of time because the repository is quite big. There's apparently some files in there that take a bit of time to download. So I'm just going to let it do its thing here, but it's telling me that it's how it's progressing. But by doing that, I'll have a copy of all those files on my computer, and then I can use tools like, for example, RStudio to generate the HTML page and see the results, see if it has worked. So especially if you've got a bigger change, if you've written some code that's supposed to generate, say, a visualization, or you're changing something quite structural on the page, you definitely want to not just submit your changes to the source on GitHub, because you haven't even tested, you haven't even looked at the result, you're just trusting that it's going to work. But you probably want to clone that repository locally, do your changes, do your testing, generate that page, see if it looks right, and then finally submit all those changes to the repository with that pull request. So that's what I'm doing here. So a bit more involved, but definitely more helpful, and it gives you more options also to use your local tools to test things, to develop code more efficiently and safely. And there's a lot of tools that integrate Git like that. There might be tools that just give you this more visual option. If you've installed Git for Windows on your Windows computer, you have access to also a tool called Git GUI or Git Guy, I think. You've got Git Bash, which looks like this, just a command line, but you also have Git GUI, which gives you a visual interface to Git. You've got countless tools to write code that integrate Git, because it's the go-to version control tool. So that's my repository cloned. If I go on my desktop, I will see the SLC LADAL website here. It's got all the files from that repository, or my copy of the repository, my fork of the repository, and it's got an R project file that I can open into RStudio. So my preferred tool to write R code, I can open that project. I've got all my files on here. I can go to my table RMD. I'm going to find it on the right-hand side. Maybe zoom in a bit. Table RMD. Find the section that we were talking about. But remember, I've already done the change on my repository. I can also do a search in here. Read Excel. And now I said I've already made my change. Well, that's a good place to talk about branches, actually. If I go back to Git and I'm in my repository here, you'll see that in my branches, there's not only master, but there's also patch 1. So here, this is the branch that automatically was used to create my modified version. But when I cloned the repository, it went automatically to master. So that's something to keep in mind, which means that now if I look at the file, I don't have the change I made. So I would have either cloned the branch patch 1, or in my case here, I'm just going to go back to it and do the change again here. So I'm going to say that it is part of the tidyverse and does not need to be installed separately. And I don't really need to change the code in any case, because it already mentions where the function comes from, read Excel. So that's all good. But now that I've got the change here in the source, I can save that change and I can click on need to generate the HTML page, and it should quickly pop up with the result on my screen with the rendered HTML page. That's not something I could have done directly on GitHub, but because I've cloned the repository, I've opened the project here, I've edited the file, and then I've compiled the HTML page, I can see what it looks like. I can go here and see, okay, yeah, that's my new sentence. There's my change, and the page looks fine. So once you've done that, I mentioned that there's integrations of Git in lots of tools. RStudio is one of them. When you are working in a Git repository, you will add this little Git tab with more visual tools. You don't have to write commands in this case. You can use those ones if you prefer to. And you can say, I've modified table RMD and table HTML. Tick those, commit those changes. Click on commit. This shows me the changes to my file. I can write my commit message. Read Excel installed, but not loaded with tidyverse. Click commit. Now it's in my history. There's also a visual representation of the history. If I go to the history tab here, I can see again that history is similar to what we saw on GitHub. There's the different versions and who recorded those versions. And if I'm happy with that, I can then go to the push button to change the remote, or send my changes to my files to the remote. And that's done. Now if I go to my GitHub repository, I'm looking at master, that's all good. Reload that page, I should see my change now pop up. Yeah, read Excel installed but not loaded with tidyverse. 1 minute ago. No worries, Temitayo, thank you. So on this branch, I'll then be able to create a pull request. Now I'm not going to do that because I think there are some differences in our system, which means that the page is not rendered the same and doesn't take into account the style of the website. So that's just something that to the side. So I'm not going to actually submit those changes. But once you've done changes to your repository, your copy of the repository, your fork of the repository, see this is still mine, I can use one of those compare and pull request buttons to send the change. But that's yeah, pretty much what I wanted to talk about today, to try and give you an idea of what it might look like working with Git, starting with the most basic commands to keep track of changes in your local repository, using those verbs to initialize, to check the status, to add changes, to commit a version that you can just use on your own, on your local project. and then checking the history of what has changed, but then getting into working with remote repositories, cloning a project, pulling changes from a remote and pushing changes to a remote to work with others, or just have a backup copy, or have a place where people can go to online and see your project advertised or published, just for transparency, for example, in research especially. I hope that was useful to you. Now, I think what I'll do is open for questions if you have any. And yeah, already thank you anyway for joining today and being interested in this topic. We do have, if you are located at UQ, you have the option to contact the library for asking questions on this topic or any software that we support.